Hi class, today we're going to do section 7.5, which is talking about inverses of logarithms and exponentials. We have already looked at inverses of different functions in the past, so the steps should hopefully seem familiar on what to do. We'll just be applying it to logarithms and exponentials instead. So if you remember back to past units, whenever we find inverses of a function, we switch the x and y's place. And then we back solve for y. And so we're going to be doing that same process, just using the logs and exponentials instead. So because logarithms and exponentials are inverses of each other, we have these little properties that we can use. Let me zoom in a little bit here. You might want to pause the video and write this down. But if we have an exponential raised to a logarithm, you can kind of think of these as canceling out with each other. And whatever was inside the logarithm is going to come out and be your answer. Same with base e and natural log. These two go together, so they are inverses of each other, so you can kind of think of those canceling, and whatever was left inside of the natural log is going to come out and be your answer. So for your property, we can switch back and forth between log form and exponential form still. So just as a reminder how to do that, if your base b is b for your logarithm, that's going to still be the base b for your exponential. And so then to go from log form to exponential form, I kind of think of just covering the log up, and it almost looks like an exponential here, but the x and the c switch places. So c will become the exponent, and whatever was on the inside for x will come out. So that's how you go back and forth between log form and exponential form, and we'll be using that a little bit as well. And then just a reminder, natural logs and base e's go together. So let's jump in to some examples. So again, the first thing you're going to do is you're going to switch the x and y's. The f of x counts as the y. You can rewrite it as a y if you want. But we're going to switch the place here. So I'm going to write this as x equals log base 3 of 2y plus 1, and then plus 5 on the outside. So that's your first step. And then now we're going to start solving for y by getting rid of everything around it. We want to isolate it. So remember your order of operations here. Do the steps in the right order. We're going to get rid of this plus 5 first by subtracting 5, so that we're left with x subtract 5 on the left side equals log base 3 of 2y plus 1. But now, since these are all inside the parentheses, I can't get to these while they're inside the log. So that's when you want to switch to exponential form in order to get whatever is inside the logarithm out. So we want to go to exponent form. So that's where you need to remember to do your change, where if 3 is your base here, that is going to be the base of the exponent. But then whatever your logarithm is equal to, that's going to come to the exponent, and then whatever is inside the logarithm comes out to what it was equal to. So kind of think of these two things almost switch places. And then once it's in exponential form, now the y is where I can actually solve for it. So I can get rid of this plus 1 by subtracting 1. And I have 3 to the x minus 5, but then minus 1 on the back equals 2y. And then we have just one more step to get rid of the 2. Just divide. And we're going to divide this whole thing. It's definitely not a pretty equation here, but this would be our inverse here. So if you remember back to when we first talked about inverses, we have that little fancy notation where we do f to the negative 1 of x, where that little negative 1 exponent represents that is the inverse. So we're going to switch back to that form. Move my paper. Instead of having a y, switch back to the f to the negative 1 inverse notation, and then this whole lovely thing is your answer. 3 to the x minus 5 exponent, subtract 1, all divided by 2. So definitely not pretty, but that would be the inverse. And then if you do kind of look at where we started versus our inverse, they do look like inverses. This had a plus 5, now I have a minus 5. this was a divide by 2, or this I had a times by 2. This was a +1, now I have a -1. So remember, they're backwards of each other, and so that can kind of help you a little bit to see that they're inverses. Let's try another one. Okay, so on this one, we have a natural log, which means we're going to be using base e's at some point. But first, before we can switch to anything, our very first step in inverses is switch your x and y. So remember, this is our y right now. So we're going to write x is equal to the natural log of y plus 2, subtract 3, and then start isolating y. So let's get rid of this -3 by adding 3 first. And we get x plus 3 is equal to the natural log of y plus 2. But then now the y is inside the natural log, so to get it out of the natural log, that's where we go to exponential form. But with natural logs, the base is a base e. So if this is my natural log, whatever it's equal to becomes the exponent. So the x plus 3 comes up here, and then whatever had was originally inside the natural log is now what it is equal to. So there's kind of going back and forth between your log form and exponential form. And then we're still just isolating y, so we're going to get rid of this +2 by subtracting 2 on each side. So I have e to the power of x plus 3, and then this -2 on the back is equal to y. But then again, with our inverse notation, we're going to switch it back to that f to the -1 of x, and then that equals e to the x plus 3 minus 2. So again, this notation just means it's the inverse of the original f function that we started with. So that one wasn't quite as ugly as the last one. Okay, let's try another one. This time we're going to start with an exponential, which means we'll probably end up with a logarithm for our inverse. So first step, switch your x and y. So we're going to get x equals 5 to the power of y subtract 6 plus 1. And then before we go to log form, we need to get rid of this +1. So let's subtract that over so that I end up with x minus 1 equals 5 to the y minus 6 power. And then now that y is up in the exponent, the only way to get it out of the exponent is to go to log form. So since our exponential is a base 5, that's going to be the base in our log. So we're going to have a log base 5. Whatever it was equal to is now going to go inside the logarithm. And then the exponent is coming out. And that's, again, the whole reason we want to put it into log form is so that this y can come to where we can actually solve for it. So we have just one more step to get y alone. We just need to add the 6 over. So those cancel, and I get log base 5 of x minus 1 plus 6. Make sure that 6 is on the outside of the parentheses. And that equals y. And then again, we would just write that as f to the -1 for our notation. We're kind of running out of room though, so that would be your answer. Again, you can usually see that they're inverses. We started with a +1, now we have a -1. This was a -6, now it's a +6. Started with an exponential, ended with a log, so you can kind of see the inverse there. Okay, let's do one more. So switch your x and y's. We're going to have x equals 5 times 2 to the 3 minus y, and then -4 on the back. We're trying to get y alone, so first step, let's add this 4 over. So we have x plus 4 equals 5 times 2 to the 3 minus y. And then really quick, I will just give a little warning right here. Whenever you have an exponential problem, this base has to stay whatever it is. I can't times this 5 and 2 and make it a 10. That's a common mistake I see students make. This 2 is stuck as a 2. So don't fall into that trap of just writing this as 10 to the power of 3 minus y. We have to keep that separated. So just kind of a reminder there. So if I'm trying to get y alone, rather than times in the 5 and 2 to make it a 10, we're not allowed to do that. So to get rid of the 5, we're going to divide by 5. So that cancels, and this whole thing over here gets divided by 5. So now we have x plus 4, all divided by 5, is equal to 2 to the 3 minus y power. And just like the last problem, to get your exponent, your variable out of the exponent, we need to go to log form. So on this one, our base is a 2, so I'm going to have a log with a base 2. Whatever it was equal to goes inside of the logarithm. So x plus 4 over 5. And then whatever the exponent was is now what it's equal to. Okay, so still trying to get y alone. First, let's minus this 3 over. I'm going to run out of space here. You have log base 2, and then x plus 4 over 5. And then just make sure that minus 3 goes on the back outside of the parentheses. And then this equals a negative y. So careful with the sign there. We don't want to know what negative y is, though. We want positive y. So to get rid of that, you can think of dividing by a negative 1, which essentially just switches all of our signs. So since this logarithm started out positive, it's now going to become a negative log. Let's see if I can squish this on here. Of x plus 4 over 5. But then because this was a minus 3, when I divide that by a negative 1, it's going to turn to a plus 3. And that would be your answer. Sorry, I know that's kind of squished. So careful when you do get those signs that you're keeping track of them. Okay. And then I lied, there's one more problem. We're going to do one more really quick with an e. So if we have a base e, we are probably going to end up with a natural log as our answer. So just kind of keep that in mind. But first step, we're still just switching our x and y's. So I get x equals e to the 4y minus 5 power minus 7. And then just be careful as you're writing these problems out that you're making it clear that this is an exponent and that this minus 7 is not a part of that exponent. So just be kind of careful with your handwriting. But first, we're just trying to isolate the y. So let's get rid of this minus 7 by adding 7. And we have x plus 7 equals e to the 4y minus 5. But then once we get to this step, I can no longer do anything while it's in the exponent. So to get it out of the exponent, we're going to go to log form, which the log form, when your base is a base e, is the natural log. So we have the natural log, and then whatever it was initially equal to, this x plus 7, is now going to go inside the natural log, and your exponent is what it's equal to. And that's how we get the y down to where we can actually isolate it. So to get it alone, let's add the 5 over first. And we have the natural log of x plus 7 in the parentheses, and then the plus 5 on the outside. And that equals 4y. So then just one more step, get rid of that 4 by dividing by 4. And so you have this lovely fraction here, natural log of x plus 7 plus 5 all divided by 4. And that would equal y, or again, we like to go back to that fancy f to the negative 1 of x notation. And that is the proper notation for it. When you have problems like this, also really quick, it's kind of ugly to write it with a big divide by 4. You can also write it like this. Dividing by 4 is the same as timesing by 1/4. So you can write it as 1/4 times the natural log of x plus 7 plus 5. And that way you don't have this lovely fraction. It's a little bit easier to write, but either one works. So just kind of an FYI, if you don't like the aesthetic of this, it's kind of just more of a visual thing than anything. You can write it with the 1/4 out front. That is inverses for logarithms and exponentials. Hopefully it was pretty straightforward, kind of following the same steps we've done in the past, of just switching your x and y to begin with and then isolating it. So just kind of some key things you need to remember is that if you need to get the variable out of the exponent, you're going to have to go to log form. Or if you need to get the variable out of the logarithm, that's when you need to go to exponent form. So kind of one of the key things from this unit is being able to go back and forth between log form and exponent form. And here's this again, if you want to write it down, kind of the steps to do that. if you want to pause the video and write it down really quick, but I'm kind of a visual person, and I just think of, if this is my logarithm, if I cover this up, it already kind of looks like an exponential with b to the power of x. But if I want to write it that way, we just switch the x and the c's spot. So that's kind of my little trick there. And then for natural logs and e's, they're just kind of their own special case. That natural log of x, you will just use a base e, and kind of vice versa, going back and forth. So feel free to write that down if you need it. But as always, shoot me an email if you have any questions or need any help, and I hope you guys are doing well.